Hello and a good day to the one that is viewing this video. So let's jump right into it. So what is back titration? So back titration is a technique used in chemistry to determine the concentration of an analyte or react slowly with a standard solution. So usually back titration involves in adding of a solution in excess amount to react with a compound in the sample. So if we take a look of from an article, according to GY 2004, back titration is used to evaluate the soil surface absorption. But in our case, in this project, we will looking forward about back titration in aspirin. So let's go. Just so that we don't confuse, back titration is very different than direct titration. Back titration done between two known compounds, but direct titration is done between a known compound and an unknown compound. And the most important thing about back titration is it is determined to determine the concentration known by the excess concentration of the unknown, while the direct titration is just the reaction between unknown and the known compound. And finally, back titration is to determine the exact endpoint when the sharp color change, while the direct titration is only the endpoint is easily obtained.
Here is the theory of back titration in aspirin. Since it is insoluble in water, aspirin has to be determined by a back titration technique. This involves treating a sample of aspirin of accurately known mass with a known amount of sodium hydroxide. There are few steps involved in the back titration of aspirin. The first step is hydrolysis of aspirin. Aspirin is reacted with an excess of a strong base, such as sodium hydroxide, NaOH. The NaOH hydrolyzes the aspirin to produce salicylic acid and acetic acid according to the reaction below. Next reaction is the reaction with excess base. The reaction is performed with an excess of NaOH to ensure complete hydrolysis of the aspirin. The amount of NaOH used is known. The third step is neutralization of excess base. After the reaction, the remaining unreacted NaOH is titrated with a standard acid such as hydrochloric acid, HCl. The amount of HCl needed to neutralize the excess NaOH is measured. And lastly, the calculation of aspirin content. By knowing the initial amount of NaOH added and the amount of NaOH that remained unreacted, the amount of NaOH that reacted with aspirin can be calculated. From this, the amount of aspirin in the sample can be determined.
Hi, I will talk about the methodology for this topic. Without further ado, let's move on to the next slide. First, I will explain the material and apparatus used in this back titration experiment. The material used are aspirin sample, 0.1 m of sodium hydroxide, hydrochloric acid, and phenolphthalein indicator. While the apparatus used in this experiment is heating plate, burette, pipette, conical flask, and also beakers. Next is procedure. It is divided into 4 parts, which is the first one is the preparation of aspirin solution, which 0.25 gram of aspirin sample was weighed and transferred into a conical flask. Distilled water was added into the conical flask and the sample was dissolved. The second one is acid hydrolysis reaction, which excess of HCl was added into a conical flask of aspirin solution. The mixture was heated and the hydrolysis reaction will convert the acetylsalicylic acid into salicylic acid. The third one is neutralization, which the mixture was cooled in the room temperature, then 2 or 3 drops of phenolphthalein indicator was added into the mixture. The mixture was titrated with NaOH solution to neutralize the excess until it changed color. Lastly, is back titration, which the neutralized solution will be transferred to conical flask. 2 or 3 drops of phenolphthalein were added into the conical flask. A burette was filled with NaOH solution as a titrant. The solution in the conical flask was titrated by adding the titrant from burette until indicator change color, which is the end of point of neutralization reaction. Lastly, the percentage of acetylsalicylic acid in aspirin was calculated. That's all for me. Thank you.
The back titration equation for aspirin involves C9H8O4 plus NaOH resulting in C9H7O4Na plus H2O and NaOH plus HCl resulting in NaCl plus H2O. The mass of the sample is 0.25 gram and the volume and molarity of HCl are 0.1 n and 150 ml. The initial volume and molarity of NaOH are 0.1 and 25 ml. To calculate the mole of HCl, multiply 1.01 with 150 and divide by 1000 to get 0.0015 mole. The excess is then calculated by comparing the mole of HCl to 1 mole of NaOH. The mole of initial NaOH is then calculated by multiplying 0.001 mole by 180 gram per mole, resulting in a 0.18 gram. To determine the percentage of C9H8O4 in aspirin, multiply 0.18 gram with the mass of the sample and divide by 100 to get 72%. This calculation helps in understanding the chemical composition of aspirin and its potential applications in various industries.
The last part is conclusion. In conclusion, the aspirin analysis used to illustrate the back titration technique is a valuable tool for accurate quantification in situations where direct methods are not appropriate. The method's dependability under control conditions highlights its significance in analytical chemistry, even with the anomaly in the percentage calculation. In order to reduce errors or improve accuracy, future experiments should make sure that procedural details are strictly followed.